A very good morning to everyone. In today's topic, we are just going to see about relational model. So inside database, how a database system works and how a relational model can be developed for any particular database architect that has been designed. Okay, so we are just going to see how it works. Okay, so previously we just saw how an entity is defined and how they are related with each other, and the relationship between those entities is defined. Okay, so we had lot of models that is associated with that. We had one-to-one relationship happen, one-to-many relationship, many-to-one, and one-to-many. So these are the basic relationship that happen between entities. So here now we are just going to see about an relational model. Okay, so we saw about an entity relationship model. Now we are going to see about purely how a relationship model is going to work. Okay, so now today's content I have just included major part as relational model and the keys that are available in relational model and how an relational algebra is depicted or represented. Okay, so based upon the word relation itself. So based upon the word relation itself, we will be able to identify how a relation model works. Okay, a relation database represents all the data in a database. Okay, so generally we use a database to store certain set of data, right? So here we are just going to store data in two-dimensional tables. So the way in which every table, we call every table as one particular entity, and how it is going to be communicated with one another, and what is the model that is standing behind the complete interface that it works. Okay, so how and two tables can be communicated by the means of what are the properties or attributes that are available inside each and every table is going to be identified. So inside a relational database model, as per definition, it is simple two-dimensional table where each row of a relational table is called as a tuple. Okay, so whenever we have a table, we can have number of columns and number of rows, n number of columns and n number of rows that is associated. So each and every row we call it as a tuple. Okay, so this is the major word we are just going to use inside our topic. Okay, so every row represent one single data, one single person's data, or one single entity's data. So that data is going to be called as a tuple. Okay, the complete table, every single value we have in that is it belongs to any one of the attributes inside that particular table. Okay, for example, you have a regional data, and inside the regional data you're just going to mark various locations, and each and every location is going to be your attribute. Okay, so based upon this we can identify how these data can be depicted. And next one is your main important aspect of your relational table. So by combining two things, we have to communicate. If two persons are in different location, they try to communicate, they should have some medium, right? So same way here, every other table. So if you want to identify that particular person's location, or if you want to know where he is, how do you communicate? You communicate via a mobile phone, right? So the particular mobile phone is a specific number. So same way, when tables try to communicate with each other, they go up with certain terms of keys. Okay, so those keys are called as primary keys and secondary keys. Okay, so we will just see what the keys are. And the main advantage of using a relational model it gives a structural independence. Okay, so the way in which the relationship is modeled, okay, so it is not completely dependent. Okay, so it is completely independent. Okay, so the data wherever inside one particular table is independent of the other. Okay, so whenever it is needed to be collated and the output has to be collated and brought, it can be brought based upon the primary keys and the secondary keys that is available inside your table. And the next advantage is that it is a conceptual simplicity. So if you want to depict anything in a pictorial representation, the way it is portrayed can be given as simple. So the design, implementation, maintenance and usage will be very easy. Okay, so if you want to define a very big architecture, if you want to define a very big architecture, at that particular time the design and implementation and the maintenance, okay, so everything has to be taken into consideration. So if these things, these constraints fall under one particular category, and the architect can be, it will be helpful for the architect to define the complete database. Next one is the disadvantages. Even though every model is successful, it has its own demerits, right? So same way here, there are certain disadvantages. One is hardware overheads, and next one, ease of design can be led to bad design. Okay, so if at all anything can be represented very easily without less number of inputs that is given to it, the idea of that particular thing may go wrong. Okay, so the design may fall into wrong place. Okay, so this is the few disadvantages. The hardware overheads and the ease of design can lead to bad design. Okay, so these are the difference disadvantages that is given for a relational model. So inside your relational model, we are just going to see what are the basic items that, terminologies that we are going to use. Okay, so before getting into that, by definition, it is an object or relation that stores the data. Okay, it is a collection of objects. Okay, so the component is going to hold n number of data, and it is also called as a collection of objects or relations. And next one, a set of operation that can act on the relation to produce other relation. Okay, so for example, you have two tables. If you want to identify the sum of salary, for example, if you take this image here, so here I have just given a table, and the salary is given in one particular column. If you are having another table, inside that you have a department ID. For example, this employee belongs to one particular employee. If you wanted to get a consolidated output, you will be able to obtain these values with the help of your relational model. Okay, and next one is your data integrity for accuracy and consistency. So this is a very important thing. Okay, so data integrity for accuracy and consistency. So every value you store inside, okay, so every particular thing that you store inside is going to be very accurate, and the consistency, the throughout the complete storage of all the records. For example, if you have a database and you are going to store n number of data inside the particular table, then what you need to do, you have to, so if you're going to store n number of data inside one particular table, then the consistency of that particular table, the record for every record. So every record, the value has to be very accurate when you store. Likewise, if you want to know it in a real-time environment, for example, if you're going to store a person's name, it has to be definitely given in string and not in number. Okay, so the consistency of that particular record need not be changed. It has to be kept as such. Okay, so this are the things that a relational model stands up with. Okay, so this is why our DBMS comes in the front line when compared to other type of database. So there are certain terminologies that is used in a relational database. A relational database can have one or more tables. Okay, so there are one or more tables that is available. Okay, so it is not mandatory, or it is not restricted to some particular figure. Okay, so any number of data, tables can be created inside one particular database, and based upon the storage, that is even more important. So based upon the storage, your table, the number of tables you store can be kept inside one particular database. So here are a few terminologies. Here we are going to see about a relation, what a relation means, and what an attribute means, and what a domain means, and what is a cardinality, and what is the degree here. So we will just see each and everything. So when you look at this diagram, so whenever, that not the diagram, the image. Okay, so when you look at this image, you have employee ID, employee name, designation, salary, and phone number. So the main value. Okay, so whenever you consider a record, if you're going to store any person's detail, it should have a attribute that is associated. Okay, so for example, if there is a person, if a person is located in, consider in one any in Chennai, consider he is in Chennai. If you want to know his identity, you will obviously want to know where he is a resident of which place, whether it is his personal address or his permanent address, I mean, or his temporary address or any kind of thing. So the values in which you store each and every column has their own individual attributes that is given to it. So okay, so for example, in this table, employee ID is one particular attribute. Employee name, the column name is called as the attribute here. So employee ID, employee name, designation, salary, phone number, all these things. So n number of attributes can be added inside one particular entity. Okay, so these column names are called as the attributes, whereas the person's name. Okay, so for example, the first record, when you see at the first record, the first record, employee ID is 125 and the employee name is Kumar, the designation is developer, salary is 25,000 and his phone number is some 10-digit number. Okay, this one single record of a person is called as a tuple or the one row. Okay, so whenever we depict a column and column name, it is referring to an attribute, and whenever I depict a row that details, it is depicted as your tuple. Okay, so you must understand the word tuple clearly. Okay, whenever I refer to tuple, it means one single row. Okay, so the row of one particular table is called as your tuple, and attributes are also, it can also be termed as the field names. Okay, so employee ID, employee name, all the employee ID and the attribute cannot be repeated. Okay, so you must make sure that whenever you come up with a relational model, each and every attribute you give a name, that name has to be unique. And next one is the domain. So based upon the domain, based upon your requirement, you specifically choose the domain, and based upon the query that is given to you, you come up with your cardinality. Okay, if you have to perform joins or if you have to combine various data together, so you come up with the cardinality. And whenever if you want to consider two entities, they are related to each other, or when an entity is connected to how many number of entity, you come up with the degree of your model. Okay, so how an entity is connected to one another, like you can say 1 to many or 1 to 10, 1 to 100, 1 to 1000. Okay, so like if you take an bank and if you have a customer for you, a bank can have n number of customers, the relationship or the degree becomes n. So if a customer is there, the customer can have maintain only one account in that particular branch. Okay, or he can have a savings account, or he can have a current account, or maximum it can extend up to 2 or 3, that's all. Okay, so this is how the degree between these relationship is completely identified. Next one, we are just going to see about the properties of a relational database. The values are atomic. Why do they tell that the values are atomic? It is more clear and it is more fragmented and it is more specific. Okay, any name you take. So for example itself, if you fill in a Google form, they will be asking a column name. Okay, I mean there will be n number of fields. So if you see in particular fields, there is a chance that they may ask the first name, the last name, the middle name. Okay, they can categorize it into three divisions, but the attribute is a single thing, but it has multiple values that is associated with it. Okay, but this is why they say that your values are more atomic. Okay, you even fragment each and everything. When consider in a huge large amount of data is getting created the day by day. Okay, so when it is moved into a warehouse, the data does not be atomic, it is just merged, or it is just combined into one single piece of information and then moved into your data warehouse. But whenever you collect an information or basic information is required, the data must be clear, so that whenever you perform a selection or a projection of one particular data, it has to be very precise. Okay, so in relational database, it is possible that every value can be atomic. Next one is your each row is unique. Okay, so every table you create, it is not mandatory that you should have a primary key, but the table you create will definitely have a primary key that is associated with it. Whenever you want to perform a relational database, I mean you want to work with a relational model, you want to communicate with another entity, you should have a primary key foreign key constraint so that it will be easy for you to communicate with the other part. Okay, the next one is the sequence of column is significant. Okay, insignificant, I mean it is not the sequence of columns. So you can create how many number of columns you need, right? So there can be n number of columns, and the sequence of rows same way. It is not restricted or restrained to one particular number that it has to precede. Next one, each column has a unique name. Okay, every column has a unique name. That's what we saw, right? Every attribute, the attribute name should not be repeated, or the field name should not be repeated. It should be unique. All values in a column should be in the same domain. So it should fall in a same domain, because every table is an entity. Okay, so entity is something that it is a collection of information about one particular domain. Okay, so it is about, for example, if it is about an employee, the table is going to hold the data of an employee alone. It is not going to include a geographical nature, or it is not going to include the climate details or any kind of sort. So the values in the column should fall in the same domain. Okay, so why there are certain rules? It's because these properties help the relational database to exhibit itself in a simpler way to understand, and it is also easy to work with. So these are the basic properties that a relational database has. Next one, we're just going to see about the keys. Okay, so this is a very important part. Okay, when you talk about keys, it is the the far most important thing, because whenever you create an entity, it ends up in communicating, right? It ends up in communicating or depending on one another. Okay, so whenever if based upon it is in the data is independent, but it needs to communicate, otherwise creating a relational database will be of no meaning. So first, whenever you need to communicate, there should be a constraint based upon which you can communicate with the other person, right? So these are the keys that stand in front, which help you to communicate. So based upon your primary key, or foreign key, or any kind of key, super key or candidate key, so these keys help you to communicate with one another. Okay, so starting with keys, it is an identifier. It is used to identify a row in a database uniquely. So that is a very important point here. So every row you take, it has to be represented in uniquely. Okay, so that's why we go for your primary key, or any number of keys can be considered, but your primary key is always unique. Okay, and your candidate key is also unique. Okay, we'll see what each and every key states. Okay, so here it helps you, the keys are one in which it helps you to identify a row in a database uniquely. This identifier may be an attribute or a group of attributes. It need not be one single attribute. It may, for example, if you see in this table, employee ID is one particular attribute. It's not necessary that your key must be one single attribute. It can be many attribute. Here a phone number of a person is also going to be unique only, right? So no two person have the same phone number. So here this employee ID and these phone number. Okay, these two things these two things can combine together to form a set of attributes, right? So your key can be in group of attributes or in a single attribute as well. Okay, so there are certain keys that are available which specifies your super key, candidate key, primary key, and there are certain possibilities for your key. Okay, so before seeing your super key and your candidate key, we will just look into what your primary key is. Okay, so your primary key is nothing but, we already saw that in our previous class. So your primary key is that it has a value that is going to be unique. Okay, so there it does not support null values. It has to be unique. It does not support any null values. Next, it is going to have values that are falling under the entities domain. Okay, so here if it is an employee table, the domain is going to be employee ID. Okay, so here the employee is the domain and the column name or the attribute is employee ID, and that has to be unique. So in this column, when you look at this image, your primary key is your employee ID. So if at all you have another column here naming that your project ID. Okay, so if this project ID, the image which is given below, that is the table which is given below, has a column name called project ID. If this project ID P123 is given along with this table, the primary key of the project table is depicted as the foreign key of your employee table. So this is how we call a difference between a primary key and an foreign key. The employee ID, I mean the foreign key of one, the primary key of one table which is depicted in another table for the reference purpose, then it is called as your foreign key. This is all about your primary key. When you talk about your candidate key is a collection of keys. It has a unique value. It also does not support your null values. Okay, you should keep these three things in mind. It is a collection of keys. Okay, so it is a collection of keys. The set, I mean, instead of collection, we can call it as a set of keys. So here you depict whenever you want to depict a candidate key, you depict it in a curly flower bracket. Okay, so inside your flower bracket you can depict the set of keys. For example, in this image, if you want to identify the candidate key, your employee ID and your employee phone number can be identified as your candidate key, out of which where your super key comes into picture. Okay, your super key is a superset of your candidate key. For example, if you have another column stating your email ID, okay, which is also going to be unique. Okay, but the candidate key can hold the values like employee ID, phone number, as well as your mail ID. But here inside your super key, which is going to be a superset of your candidate key. Okay, so here you can have null values. This is the main difference between your candidate key and your super key. Employee can have a employee ID, can have a phone number, but based upon his cadre or based upon his, I mean, in any other, consider there is no, if an organization runs, it is not necessary that only, for example, if it is a college, it's not necessary that only students and staff should be there. There is a management department, so many people work there, and there is another department which is cleaning, so many people work there, and so many others. So it is optional for the employees to have mail ID or not. Okay, so there is an option. So whenever there is a mail ID, that is definitely going to be unique, but the option is given there where an employee ID, phone number, and email ID can be considered as your super key, where the super key includes your mail ID, where the mail ID can be null at any cost. Okay, so it is not necessary that it has to be null. It can have values, or it also accept your null values. So this is how we categorize our main keys. Okay, so one is your primary key, foreign key, super key, and then your candidate key. Okay, there are certain properties. So the value of a primary key must not change. It has to be stable till the existence of the table. Next, it has to be minimal. Okay, it should be composed of minimum number. Okay, and next one is your alternate key. Okay, so alternate key is also called as your secondary candidate key. Okay, it also belongs under the category of your candidate key, but it is also called as your secondary key. So here in this example, if we see email ID, phone number, and your mail ID, so mail ID can be considered as your alternate key. Okay, so if at all any database is there, all the employees, if they have a mail ID value, and each mail ID is going to be unique, and that at that point in time we can use alternate key as your mail ID attribute. Next one is your composite key. So composite key is nothing but it is a collection of keys. Okay, so here you can have a composite value of employee ID, name, designation, all these together. So these set of keys can be considered as your composite key. So these are the basic things that you have to know before you can see what what a relational model looks like. So when you understand this clearly, you will be able to understand how a relational model works. So we'll move on to the next part, that is your relational algebra. So here the relational algebra is a procedural language. Okay, so the term itself specifies that it is going to be with some operations. Okay, so you're going to have some operation that is going to be performed with some relations. Okay, so with some outputs that you are going to just given. Okay, for example, if you are given a query, you work and you depict that particular query in a relational term. Okay, so a relational algebra pattern. So the basic operations here we use is your select. Okay, select is defined by the term sigma, and project that is defined by the pi, and union is defined by the symbol u, and set difference it is given by the minus, and Cartesian product. So and we'll see each and everything separately. And next one is your rename. So here you have select operation, you have project operation, you have union, set difference, Cartesian product, and rename. So the basics of your database teaches you how you do a select process. If you want to identify any value, or if you want to look into the table, okay, so if you want to look into the table completely, if you want to identify, or if you want to know the complete table values, you do for a select, you go for a select operation. In normal DBMS, when we write a query, I mean if you want to write a query, you give it a select star from the table name. Okay, you all the records in your database, I mean in your table, just list, it gets listed. Okay, all the attributes, all the tuples, everything in your table gets listed. So you can also restrict the data by selecting or by using where clause in it. Okay, so you can just concise it, and you can just bring it up into small number of selections based upon how you want to project the data. So for select operation, we return number of rows of selection. Okay, so that satisfies your condition. If you use just star operation, you just display the result. But here the syntax of your relational algebra for select operation is that you start with your sigma, then the selection condition. So any condition, if any condition you are just going to give in, then you have to give it inside the condition braces, and then you can give your relation. Okay, so with relation is R, the relation table, the table name is going to be your R. Okay, so R is going to be your relation. So in this table, your relation name is employee. Okay, the name of the table is employee, so your relation R is going to be employee. Next, your selection condition. If you want to get only the record of Raju, then you can write a select option here, or else you can just go ahead with your sigma, and then bracket, inside the bracket you can just give employee, so it will list so many values that is available inside. What all the values inside your table will be listed here. So if you want to do any particular selection, you can do it with the help of this. So for example, if you want to write a query, sigma selection condition and result. For example, like as I said, sigma EID is equal to 125. Inside the bracket, if you give it as employee, only the record of Kumar will be displayed inside your table. So this is how we do a normal select operation in your relation algebra. Okay, so whenever you use the sigma in front of your representation, algebraic representation, then it means the select operation is going to be processed. It is there are two main things you have to know inside your selection or your relational algebra. One is your selection, and next one is your projection operation. So selection helps you to draw all the rows that are available. Okay, so next one is your projection. So when you talk about projection, it extracts value from a specific attribute. For example, if you want to display all the name, then you go for projections. Okay, if you want to display only the phone number of the particular phone number of all the employee, then you call that as your projection. We'll see what a projection is now. So here I have just given an example. So here query is given. The small query depicts one particular result. So when you look at this previous slide, here we had 5 records of so many employees that are available in one particular organization, and next when you want to get the value whose salary is greater than or equal to 30,000, the name alone is listed here. So the query, you write it in this form. Okay, so if you want to go for any exam, and if you want to approach a GATE exam, the question will be in this format. Write a relational algebraic query for a particular scenario. For example, if you want to select one particular student name whose phone number is 8561234568. So this is going to be the phone number. So if you want, so the scenarios will be given and you will be asked to write your query statement in between. Okay, so the complete scenario will be given there. Okay, so scenario or the table, or even at some question papers, the attributes will also be given there. This is going to be your entity name and the attribute names will be so and so, and you write a relational algebraic query that is going to get or list few values inside. Okay, so this is how we just see an example in the later part of this class. So here we are just getting the select value. Instead of writing select salary from employee where salary is equal to 30,000. So or select star from employee where the salary is greater than or equal to 30,000. So instead of writing this query in a relational algebraic model, we represent the query in this particular format. Okay, and the next one is going to be, I've just given a small question here. So here the selection operation in an SQL is equivalent to. So when you look at this question, there are given certain options. So first thing what you have to do, you have to go through all the options. Okay, so you have to bring up the answer to mind and then you have to go through your options. The first option is selection operation in a relational algebra. So SQL's relation operation and your algebraic relation operation is equal or not has to be looked into. Next one is your selection operation in algebra, except that select SQL retains duplicates. Whether is this correct? No. Next one, the projection operation in relational algebra. Is it equivalent to the projection operation? We already saw the selection operation displays every row. Okay, so we must look into the next part, the projection operation in a relational algebra, except that select in SQL retain duplicates. Okay, so it is going to be a your selection operation is equivalent to your projection operation in your relational algebra, and except the SQL retains. Okay, so here I've just given the explanation. Select operation is equal to the projection operation. So we saw already what a projection operation is, right? It extracts a value from your specific attributes, that is your complete column attributes. Okay, next, in a relational algebra, except that it select SQL retains duplicate. Okay, so here in certain aspects it does not retain duplicate values. Okay, so here it retains the duplicate value on the contrary to the projection. Okay, why? Because the projection operation will always consider, for example, if you have a 10 employee names and you do a projection operation based upon their department ID, there are possibility that 4 people can fall under one department, the rest of the 6 people can fall under another department. When you do a projection operation on that particular table, you will end up getting only 2 records, since you have done a projection operation on the department attribute. Okay, so if at all you want to perform a SQL which is equivalent, the projection operation is same as your relational algebra, but it retains the duplicate values. Okay, so this is how it has to be given. Next, which of the following relational query language is same expressive power? Okay, so we just give the set of query languages here. One is your relational algebra. Next one is your tuple relation calculus restricted to safe expressions. Domain relational calculus, which is restricted to safe expression. Okay, so there are so many possibilities. They are asking that which one is a is more expressive. Okay, it is more meaning powerful when compared to the others. Okay, so we must, before answering this question, we must actually know what a relational algebra is, and what is a tuple relation calculus. Okay, and what is a domain relation calculus. So as we speak, we are just studying about what a relational algebra is, right? So it is how, in the way in which it is getting depicted. Okay, so depicted of how we represent your particular query in a relational algebra. Excuse me. So first we are just now looking into the looking at what a relational algebra is, how we represent queries inside one particular relational algebra. Before answering this question, you should also know what is your tuple relational calculus. It is a tuple relational calculus. For just information, I'm just telling you, it is a procedural query language. Okay, which is related to the records. Okay, which is related to the records. So based upon that, your predictive calculus happens. Okay, so based upon that, your predictive calculus happens. So whereas when you talk about your domain relation calculus, it is restricted to the list of attributes. Okay, so it is based upon the rows. This is based upon your domain relationship, based upon your columns. Okay, that is your attributes, or you can also call it as your fields. It is same as the tuple relational calculus, but both are similar. Okay, the selection, the pattern in which the data is extracted from the table alone differs. Okay, so we'll just see what the options are given. So there are four options given. One, either it can be 1 and 2, or 2, or 2 and 3, and 1, 2 and 3. Okay. So now we know what a relational algebra is, what a tuple relation is. It is tuple relation is nothing but it is a procedural query language. It is identifying only set of rows, that is your tuples, whereas domain relation calculus, where domain relation calculus is related to your attributes. Okay, or your fields. Okay, now when you understand this, when you compare all these three are very expressive. Okay, so when all these three work together, it gives you a good good optimized value. Okay, so for any query you run, it gives you a optimized execution. And next one is your projection operation. So when we talk about your projection operation returns specified attributes. Okay, so we saw, I mean, we are just identifying what is your selection operation and your projection of project operation. Okay, so this process, you can also call it, it is projection project operation, but you can call it as your projection operation. Okay, so you focus on the attributes. Okay, you just focus on the attributes, whereas when you look at the syntax of your selection operation, it gives you the selection condition and the entity that it belongs. Okay, or the table that it belongs. But whereas when you look at this projection operation, it gives your attribute list. It concentrates only on the attribute list and the table from which you are going to fetch the attribute. Okay, so for example, here a query is given. The table, from that particular table, what are the things that you are going to extract? You are just going to extract the attribute and the salary of the employee. Okay, so here when it is defined as pi, or when it is notated as pi, okay, the notation is going to be pi, then it means it understands that it is going to be a projection operation where name and salary of all the employee is going to be listed in the particular employee table, from the particular employee table. So this is how your projection operation works. Next one is your union operation. So your union operation is denoted by the symbol U. Okay, union, as we know, it is already the combination of all the data that you have, but it removes your duplicates and gives you the values. Okay, so for example, here you have the values that is given here. So when you look at this output part, okay, so when you look at this output part, when you look at this output part of the entity R and entity S, the tuples have four names, but here the tuple also have four names, but the name Kohli is just repeated here. So here you have a value that is given here, that is the union operation happens and the output is given here, okay, after executing the query. So you depict your union operation with the help of the symbol u, okay, with the union symbol you can depict it as u. Next is your set difference operation. So set difference operation, when you talk about your set difference operation, in this operation it gives about r minus s, that is your set difference operation. So that includes all tuples that are in R but not in S. Okay, so the first table, whatever we have given here, is taken into consideration, but it is not in S. Okay, so it has to give all the values which is not in S. So what are the values that is available here? Sachin, Dhoni, Dravid and Kohli, but the output has only Sachin and Dhoni. Okay, so Sachin and Dhoni, because Dravid is already there and Kohli is already there. Okay, so here the values is getting, it is doing a difference operation based upon the entity R. Okay, so based upon the entity R, it is just removing the values that is not, that are in R but not in S, and it is giving you the difference. Okay, so what are the things that is not in R, not in S but in R? Sachin and Dhoni. Okay, so this is how we perform a set operation. The main thing that you have to keep in mind is that you have to know what is your notation for each and every operation. So here we use pi for your projection operation, sigma for your selection operation, next u for your union operation, and hyphen for your set difference operation. Or if you want to perform any deletion or removing from your table also, you can depict it with your minus symbol. Okay, and next one is your Cartesian product. So Cartesian product is nothing but you produce a new element by combining every member from other relation. Okay, so for example, you have a table called employee, you have a table called project. Okay, every employee is related to some particular project. If you want to identify him in that way, if you want to find out a Cartesian product, it is just like a simple multiplication operation. So every employee, for example, when you do the output for, when you write a query for a Cartesian product for employee into project, then you find an output saying that all these 5 records into this 3 records, and it should give you a 15 value table. Okay, so here it will include attributes name such as employee ID, name, designation, salary, phone number, PID and P location. So we'll just see the output. So it gives you a employee ID, name, designation, salary, phone number, and this part of this image, when you look at it, it is your employee ID, PID and P location. Okay, so all these value combined together forms you a Cartesian product. So the Cartesian product query is that it gives employee cross your project. Okay, so this is how a Cartesian product is notated. Okay, so with the help of into mark, it is just notated. Okay, so then you get a final output of 15 values where you get all the combination of both the tables, employee table as well as your project table. Okay, so here when you look at the values index, you have Kumar, you can have a project ID of P123. He can also be the part of project P225, and he can also be the part of the project P556. Okay, so same way Raju can have the can be a part of the project P123, P225 and P556. Okay, so this is how a Cartesian happens. Now, so whenever if you have any table that does not have a primary key or any constraint, okay, so we'll see in further examples, if you're not able to combine those tables, you can perform a Cartesian operation, or other than that you can perform a neutral join to combine the tables, and then you can get an output for your particular query. So next one is your rename operation. Okay, so this rename operation helps you to change the name. Okay, so change the name of one particular value. So what are the values that is going to be done here? So which the worker is going to be changed here. Okay, so the worker from the employee name. Okay, so here the name of your table. Okay, so P, the worker, is going to be getting changed here. 1 second. The name is going to be changed as your, instead of employee, it is going to be changed as your worker. So here next one is your intersection value. So when you do an intersection process, the entity R and S, what are the entity R and S value name is given here. So 4 names from R and 4 names from S is given here. The intersection, the common value between these two tables will be given here. Okay, so what are the common names that is available? When you did a set difference operation, we got the output as Sachin and Dhoni, but whereas when you do an intersection operation, you have the common values like Dravid and Kohli. So these two values will be given inside this particular part. Okay, so this is how we do an operation. So I mean your intersection operation, or you can also, we saw how to do a union operation. This symbol denotes your intersection operation. Next one, I have just given the way how a selection operation is done. Okay, so if you want to identify a selection operation, it happens based upon your rows, whereas projection operation happens based upon your attributes. And we saw what a Cartesian product is. It is denoted by an into mark symbol. So here when you take the set of P elements and the Q elements, I mean P entity and the Q entity, you get the product of the records. And when you see a union operation, it is the combination of your R and your S. Okay, this is a combination of your R and your S entity. Okay, and if you perform an intersection, the values that are in common will be given as the output. When you talk about your set difference, the value which is not in S will be, but it is present in R, those value will be given as the output. Okay, so this is how the operation or the set procedures has is working. Okay, so next one, I've just given one more example here. So this is one of the given previous year questions. So consider the relationship R1 PQR and R2, and it has the values as RST with the primary keys as T and the primary for the other table the primary key as R. Okay, for R1 stands P stands as the primary key for R1, and P R2 for R2, R stand as the primary key. The relation R1 contains 2000 records. Tuple means record. Okay, so we know that, right? And R2 contains 2500 tuples. The maximum size of the join. So when you do a join operation for these two, so what will be the output when you do a join? All the values that are common for these two will be given here. So the primary value is taken into consideration. So the output has to be 2000. So here when you look at the answer, it is 2000. Okay, there is one more question. We'll just look at this question. Consider the following relational database of a college. Okay, so they've just given a question here, and they've also mentioned the entities and attributes along with it. Okay, so what are the attributes that is given for here, given for this particular image? So student has 3 attributes. It is roll number, student name, and address. Teacher has 3 different attributes: teacher name, teacher ID, and teaching subject. And the third one is your college entity, which has your roll number and your teacher ID. So there are few queries that has to be written in a relational format. Okay, so in a relational algebra format. So you can write your SQL or a relational algebra expression for the following question. So to find the name of the student who lives in Lalitpur. So here we are going to consider the entity student. So what is the entity consist of? It consists of 3 attributes. Okay, your roll number, student name, and address. Here they have given the address as Lalitpur. So inside your Lalitpur, there may be n number of students, or there may be a single student also. So what you have to do here, you should perform a selection operation or a rejection operation. So you're going to select one student. belong to based upon certain criteria. Okay, so that student belongs to the address Lalitpur. Okay, so if you want to fetch a record from that format, you have to use the relational operation pattern. Okay, so one is your, so for performing selection operation we go for your sigma value, right? So you can give your sigma value. So find, here I've just given the question here, find the name of the student with Lalitpur. So here we have three tables. One is your student table, teacher table, and then your college table. Now, if you want to select all the student name from your student entity, you can write the query as pi student name. Inside your brackets, you can give the complete table name, that is student. Okay, but here what in the question they have asked that only the address. Okay, so the student having the address Lalitpur has to be selected. So what I'm just going to do here, I am specifying my attribute name here. Okay, the attribute, what attribute they've asked, they have asked, the output they require the student name as the attribute, but under what constraint? The constraint or the condition is going to be your address is equal to Lalitpur. Okay, and from which table you are going to get the value? From the table student we are just going to get the value. Okay, so based upon this identification, this is how you write an relational algebra query. Okay, so if you going to do a selection process, you have to do it in this way. Okay, so here the student name is going to get displayed from where the where condition is going to be your Lalitpur, and from which table you are going to fetch the data, it is going to be student. Okay, so next question, we'll just see what is the next question. So next question is that find the name of a teacher who teaches database management system subjects. Okay, so you're just going to identify the teacher's name. Okay, here you have a table with table name teachers and the ID, teacher ID. Every teacher has a teacher ID, that is going to be your primary key, and teacher name. What is the teacher's, I mean, it is another attribute. Okay, so here you have your teaching subject. So based upon this column, because the data given here is the subject name. Okay, so based upon this attribute, okay, we are just going to write a where clause based upon this condition. Okay, so teaching subject, and your teacher name is going to be the attribute that is fetched. Okay, so we are going to work on the teachers table. Okay, so here the teacher table is given here. Okay, so the first thing, find the name of the teacher who teaches DBMS. Okay, so here I'm just going to identify the teacher name. So here it is not supposed to be student name, it has to be teacher's name. Okay, so in teacher's name, then your teacher's subject has to be given here. So since it is a string, I've just given it in double quotes, and then I've mentioned the subject name there as DBMS. And next one, I'm going to fetch the data from your teacher table. Okay, so teacher is going to be your entity here. So from the teacher table, I am deriving the subject name as database management, and I'm just going to display my teacher's name. So this is how you select a, this is how you perform a selection operation in your relational algebra. So this is a relational algebra expression which depicts the query, that is find the name of the teacher who teaches DBMS. Okay, so this is how the question will be projected, and you have to write the algebraic expression for that. Okay, and next one is that, so now here when you look at this question, find the name of the teacher who teaches computer organization and architecture to the student John. Okay, so it is even more specific. Okay, so if you, when you look at this question itself, it is a combination of two tables. So you're going to look into teacher's table as well as the student table. Inside your teacher table, you don't have a column called student name, so you'll not be able to fetch it. And next one, inside your teacher table, you don't have, I mean inside your student table you don't have any subject name that is given. Okay, so you inside the student table you have only roll number, student name and address given to you. Now it is up to you how you have to write the query. Okay, so here main point that you have to keep in mind is that no common attributes are available for student and teacher table. So you have a primary key for this table student and you have a primary key for this table teacher ID, but there is no foreign key in between so that you can refer and pick the data. Okay, so you don't have a foreign key or you, so it is obvious that you have to join all these tables, you have to perform a join operation, you have to combine these two tables and you have to derive the output. Okay, so how do you perform a join operation? This is the way in which you depict your join operation. Okay, so it is kind of a somewhat like a infinity symbol. So inside that you perform a join operation. Okay, so for what join operation, how you can perform here, when you look at this table, the common thing in student versus college is your roll number and common thing that is in teachers is with your teacher ID. Okay, so based upon this you have to perform a natural join operation, so which combines all these three tables together, and then you will be able to fetch the name of the student, name of the teacher who teaches COA subject for the student John. Okay, so this is how you have to proceed. Okay, so because there is no common attributes that is available among these two tables. Okay, so when you perform your join operation, this is how it looks. So you are just going to get the name of the teacher. Okay, so what is the teacher's name and what subject she is going to handle, and along with that you have to be specific with your student name. Okay, so the student name, all these value will be fetched only when there is a join that has happened between the student table, teacher table and college table. Okay, you can't perform any other join, so you can't perform other joins to fetch these data. All these three things are essential to identify how when you perform your join operation, your all these values will get gathered up together. Okay, so it will, you will have lot of null values where these values cannot be placed. So wherever the teacher ID comes in, the student will have a null value given there. Wherever the teacher name comes in, the student entity will have a null value given there, and the teacher subject will have a null value. Okay, so this is how you perform a natural join. Okay, so when you perform a natural join, you will be able to obtain the values. Okay, so here there are two common values inside your college, so that is your roll number and your teacher ID. Excuse me. So when you perform a natural join, it creates an join clause. Okay, so all the columns, okay, or all the common columns in the table are joined. So for example, roll number and your teacher ID, all these things will be joined, and then you get an output for that particular join. So only then this front part, that is your teacher name and your specification about your subject name and the student name, will work only you perform a natural join between these three tables. Okay, so this is a notation of how you perform joins. Okay, so this is how you perform join operation. Next one is that insert a new record. Okay, insert a new record into a teacher table. So for inserting one particular value inside one table, the algebraic notation has depicted a forward pointing and backward pointing arrow mark. Okay, so arrow mark has to be given for that particular data. Okay, so here I am just marking the record has to be entered into a teacher table, dot must not be there, and it has a union operation that is given. So what are the things that you are going to insert? Three attributes are there: the teacher ID, the name of the teacher and the subject teacher. Okay, so based upon these three values that is given, the algebraic expression can be represented. Okay, so T tends to, you can insert it in the record into the table teachers, and by combining all these three values. Already, for example, if the teacher table has 10 values that is given inside, and this is going to be combined with the previous values. Okay, so it has to be given along with that. Okay, so when you do a select operation of that, it has to fetch all the values that is given. And next question. So next question is that delete a record of student whose address in Pokhara. Okay, so here we have a student, teacher and college table. So you're just going to delete the student from whose address is going to be Pokhara. Okay, so here if you want to do the delete operation, okay, so you're just going to delete the student one particular entity or n number of entity. Okay, there may be 5 or 6 students from the same locations, right? So if you want to specifically delete that particular value, you perform your project and your selection operation. What you're going to select, you select the address. Okay, you select the address of the student. Okay, so from which table you're going to select, it is going to be student. Okay, that entity is going to be student, and he can depict, or he can remove all the student values. Okay, and then he can do a deletion operation, and then you can get a minus value, and then the complete record of that particular students, or the how many number of student who has the same address will get deleted. Okay, so this is how you perform a deletion operation. So there are certain questions, so we'll just walk through all the questions we saw. So here there are given 3 number of tables, that is your student, teacher and college. So when you want to find your student, you perform a selection operation, but your where condition is going to be your Lalitpur. You write your algebraic expression. Next one is going to be your same pattern. It is going to have your teacher who teaches your database management. That time you have to give your pi for your projection operation of your teacher's name, and then for selection operation you have to include your subject name, and then which subject that is going to be that staff is taking has to be mentioned there, that is DBMS. From which table you are going to fetch the data, that is teachers. So you have to give it in that format. Next, find the name of the teacher who teaches your computer organization subject, and the name of the who is taking CO computer organization subject for the student John. Okay, so we have to check on whom the value is attributing. Since all these 3 tables does not have a common attribute in, I mean does not all the 3 tables, student table and the teacher table does not have a common attribute, so that we move in for performing a natural join operation. Okay, that is combining your 3 entities, that is your S entity, C entity and your T entity. All these 3 entities has to be combined. Then after combining all these 3 operation, we perform a selection operation between the subject name and your student name. Okay, so intersection symbol denotes your AND operation, and while performing the AND operation you will be able to identify the particular teacher name who is handling the COA subject for John Smith. And next one is that you find how to insert a new tuple into a relational database. So you have to use union for inserting. Okay, union for combining your data with your previous value, and your arrow mark for inserting a new record. So T arrow mark, T union, your set operation opens. It includes all the attribute value, teacher's ID, teacher's name and teacher's subject. Okay, next one is that you find your delete records of your student who is in Pokhara. So for delete operation and set operation, we commonly use your hyphen symbol. Okay, so with that help of your hyphen symbol, it will just get removed. Okay, so when you perform that on your, you will perform the negation symbol for your student column, and the data who are, whose student has been removed. Okay, so if you perform a minus operation, the data will be removed or it will be deleted from that particular table. Okay, so these are expressions of queries. Okay, so to depict one large query, we go in for a relational algebra and then we concise it into a smaller part. Okay, 1 second. So these are the expressions in which we depict each and everything. Okay, so you can perform your selection operation. So there are totally more, not only these operations, there are so many number of operations that can be performed under each and everything. Okay, so your selection operation is denoted by your sigma symbol, your pi operation for projection, your union operation is denoted as u, your set difference operation is denoted as your curly brace symbol, and your intersection of Cartesian operation is depicted with an into mark, and your set difference by minus, and your deletion operation also you can use the same notation as minus for deleting, and your arrow mark for your insertion operation. Okay, so we will continue with the next part, continue the remaining of tuple calculus in our next session.